In this video, you are going to learn about the internal consistency and standard error measurement when you're analyzing a test. First, remember that these data are for educational purposes only and shouldn't inform your opinion about the subject matter. So the data aren't real, and they're just here for learning purposes. First, we are going to load some packages. And then we're going to load in our data that we'll use. If you're following from previous videos, you've seen this explained a little bit, but what's relevant today is that here are multiple choice items, and these are just codings. It doesn't matter what they mean right now. What's most important is that this is one multiple choice item, another multiple choice item. The 1 means the test taker got the item correct, and a 0 means that that test taker got that item incorrect. And here are some speaking scores. But right now we're going to focus on the multiple choice items. When looking at internal consistency, we're interested in a statistic called Cronbach's alpha. Here we're inputting in these columns that represent our multiple choice items scored. So we run that code, and then we look at Cronbach's alpha. You can see that this is the overall Cronbach's alpha for those items. And we also run a couple functions in order to get the standard error of measurement. Now, this function is designed to pull out the standard deviation from a much longer output. But we can look at that longer output first to understand this code. So if we just run this code, and I'll make a quick change, we can see that we get a long output like this. And right now we're specifically interested in the standard deviation, which is the 14th row, which is what this means. So we run this code, and then we just get the 14th row's output here to here and save it to this variable. Here we see our formula for the standard error measurement. That's the standard deviation times square root of 1 minus Cronbach's alpha. So we're going to use the Cronbach's alpha that we made previously, put it into this formula, and that's going to give us our SEM, the standard error of measurement.